Hello and welcome to CIC Start Online webinar here at Glasgow Caledonian University. My name is Branka Dimitrijević and I will moderate today's event. Our webinars disseminate outcomes of feasibility studies and academic consultancies undertaken through our project. The project supports collaboration of 7 Scottish universities and Scottish small to medium size enterprises to develop and test innovations for sustainable building design and refurbishment. The project is funded by European Regional Development Fund and a CIC program of Scottish Government, now managed by Scottish Funding Council. Before I introduce our speakers today, just a few housekeeping points. As usual, if there is a fire alarm, we will have to stop and continue later. If you cannot join us later, you will always be able to watch video recording of this webinar. We plan to finish with presentations around 1:30. However, you can start asking questions by using chat facility at any time during the webinar, and we will answer these questions in the Q&A session after the presentations. We will close at 2 o'clock, but if not all questions are answered, email will be sent with answers to all unanswered questions. So today's seminar title is Energy Efficiency Retrofit Cost Benefit Calculator. This was a feasibility study that was undertaken by the researchers at the School of Architecture, University of Edinburgh, at Heriot Watt University, by researchers at Heriot Watt University and Changeworks Ltd. Our speakers today are Stuart Hay, Senior Consultant at Changeworks, then Bob Barnham, Senior Project Officer at Changeworks, and David Jenkins, Research Fellow at Heriot Watt University. So I will now hand over to our first speaker, Stuart Hay.
Good afternoon to everybody. Good afternoon to everybody online. Thank you for taking time to attend this webinar. This is the first webinar I've done. It'll be quite interesting. And it's also been, I should warn you, it's been broadcast out of Glasgow. But the good news is that has nothing at all to do with football. So if anybody's worried about that. So the first thing I need to do is thank CIC Start and Scottish Enterprise for making this collaboration with Heriot Watt possible, and also to thank Bob Barnham, Gary Pearson, and David Jenkins for working on the project. This is an important project for us in terms of developing a retrofit cost calculator tool. It's important for a number of reasons, because we do need to improve quality of our buildings in Scotland so we can meet our carbon targets. Fuel poverty is obviously rising rapidly as energy prices rise, and we need to respond to that challenge. And we've been concentrating too long on the easy wins, the easy to treat buildings where you can do simple things to them, where there's not a lot of modelling or technical work that's needed, but we now need to look at more complicated solutions for the harder to treat buildings. And this is something that's particularly pertinent to social landlords and landlords more generally that have a portfolio of properties which they need to improve and retrofit. So this seminar I was going to discuss the design tool and what it does. We've been doing stock analysis for a number of years, and it's becoming more and more important as retrofit becomes more important. This particular piece of work began in 2011 when we were working with the City of Edinburgh Council, and they were particularly interested across their stock and what they could do with the hard to treat properties. And this is a problem that most social landlords will have. And in the future, as regulations change, other landlords will also start to think about. So we did some initial assessments. We created a spreadsheet-based tool that took their stock data, and we worked on a number of archetypes. And Bob's going to explain how that process worked. We didn't feel we had the tools to do the job as effectively as we would have liked, and we needed to become smarter and develop a tool that would be more effective, allowing us to do this. and that led to the collaboration, which was only possible through the funding we got from Kickstart. What we created was a tool that utilizes a range of existing modeling software, but it will now allow us to model a portfolio of different hard-to-treat property types and sub-archetypes as well. And the most important thing is it matches this up with a database of costs, which gives you not only what you're saving in energy, but actually the actual cost base of different strategies. It utilizes actual data on the dimensions of the property, so it's much more accurate than other tools in terms of what the cost it produces, particularly for things like solid wall insulation. It also allows us to determine quite easily whether a minimum standard, at the moment is the minimum standard set by the Scottish Government that are in the model, are being met, and it does that automatically. And it models the risk of fuel poverty based on income thresholds, so we can tell a social landlord if particular properties are going to pose problems for tenants on low incomes, and they can manage their letting policy accordingly. And finally, although we're still to fully test this, it will model the golden rule in relation to the Green Deal, measuring whether you're actually going to get the savings you need to meet that golden rule. Bob Barnham and David Jenkins are going to talk a wee bit more about the technical part of this. We've been working with Heriot Watt for a number of years on some interesting projects. One of them was a technology strategy board project in relation to a comprehensive retrofit of a timber house, which was modelled, and we had to cost that up. And that was the sort of starting point. That was an interesting project in terms of how much and how complicated these projects could be. We also collaborated on a bid to Fife Council to do some stock analysis work, which we didn't actually win, but it was a good experience, and also highlighted that we need to develop up our capabilities in that respect. And this project will help us do that. I'm going to hand over to Bob Barnham now, because he's been at Changeworks much longer than I have, and he can give you background on this project and other projects that it relates to.
Thank you, Stuart. Good afternoon. Changeworks, it was previously known as Lothian and Edinburgh Environmental Partnership. It was set up in 1990 as a partnership between the public, private, voluntary and academic sectors, so it's good to be in another academic institution today. It's a voluntary organisation, a registered charity and company limited by guarantee. It currently has about 120 staff. Our two main office bases are Edinburgh and in Inverness, but we also have satellite operations across the Highlands and Islands. It manages two of the Energy Saving Scotland Advice Centres in Scotland, one for the southeast of Scotland, so servicing all the households who live in the southeast Scotland. The second centre covers the Highlands and Islands, so it's a very disparate area in terms of housing stock, comparing urban Edinburgh to rural areas, for example, covered by the Highlands and Islands Advice Centre. It's quite a challenge. As well as providing energy efficiency support, we also give advice on renewables, transport to advice to households, but also we support small businesses. This is the programme that's funded through the Scottish Government. Our remit is sustainable development, and our current portfolio includes energy-related projects and renewables, waste prevention, transport, and environmental education, and it extends to consultancy services for a broad range of clients. A key partner for us, however, is the City of Edinburgh Council, which is represented on Changeworks board and which has financially supported us from the very start when the organisation was set up in 1990. I'm sorry, I should have shown you that slide earlier. Right, Changeworks projects and partnerships. We've been working with councils, housing associations and cooperatives since the inception. In fact, Changeworks was set up to enable us to channel funding into the city to carry out energy efficiency improvements on housing across the city itself. Project-specific work with social landlords. You've got 3 images here, which I'll talk about in a minute. We've done a lot of work on stock option reviews to looking at achieving minimum standards and affordability. One of the issues in relation to social housing is that people may be in employment obviously one day, but then the next year they may be benefit dependent. So how do you enable them to retain a stable tenancy and afford to heat the home to comfortable levels? The 3 photographs on this slide, the top one is Cableswynd House in Edinburgh, and we've done modelling work on this for the City of Edinburgh Council, who put in a really interesting new heating system and are putting in insulation into the building. The challenge with a building like that is that it's got about more than 20 different sub-archetypes. So you think what you know about the individual properties, but within the building there are properties with very different characteristics because of their location, are they ground floor, mid-floor, or wherever. So you really need to take into account the particular characteristics of each and all of the properties you're going to be modelling. The image at the bottom right is one of the multi-storey buildings in Craigmillar, and we've been looking at this in terms of modelling, but we also looked at it in terms of validating some of the options that the council was keen to pursue using funding through the power companies. And we were able to look at characteristics of the existing construction of the building, particularly cold bridging and some of the prefabricated elements, to assess what were the real ways that we could actually help the council do things to the building to actually come up, meet the most challenging standard, which at present is 2016, which is the Scottish Housing Quality Standard. We know that that is going to change over time, and so it's a challenge for us to be planning ahead of ourselves. In terms of energy efficiency and renewables projects, we've done a lot of pilot work. The 3rd image on this slide is a thermal image of some Georgian tenements in central Edinburgh. If you look at the image, to the left of it you've got a red and yellow image, which on the temperature scale demonstrates that the majority of the heat loss, well, the key point of heat loss through this wall is not actually the historic Georgian walls, which are about 75 centimetres thick, but it's actually through windows which have been untreated. The ones to the right of that have actually had various treatments put in. They've had shutters reinstated, draft proofing, and in certain cases, secondary glazing. So thermal imaging is something that we do a lot of because it both validates, but it also identifies work that can be done. For example, we are currently in partnership with a contractor who is going around Edinburgh with a van taking thousands of images of properties and their heat loss. In terms of pilot work, we've been putting solar panels on historic roofs very close to the castle in Edinburgh. You can see on this slide, the bottom left image is Renewable Heritage, which is a report that you can download off Changeworks website, which talks through the options for renewables retrofitted into buildings, but it also has a case study where the image, the top left image, is of a significant number of solar panels providing solar hot water to tenants through a 5-storey Georgian property. Hadn't really been done before. In this situation it was easy to do because it's all in one ownership, but our challenge in Edinburgh is that 45% of all property in Edinburgh is tenemental, so it shares a common stair, and for a lot of those properties they're in mixed ownership, and therefore it's a challenge to get everyone working together. Before we leave this slide, can I just refer to the web address www.changeworks.org.uk, which is where you can download PDFs of renewable heritage and a range of other technical reports. We have been involved in lots of modelling work over the years. We've used very early sort of BREEDEM tools. We've used Energy Auditor. We've been using various levels of National Home Energy Rating software, SAP calculators. We've also been very early entrants using RD SAP, which is the thing that generates, if you're not familiar with it, it is a reduced data SAP. It generates energy performance certificates, which will inform Green Deal assessments, but also the EPC rating on a property, which currently is not an MOT, which says pass or fail. It looks as though the standards will become more stringent over the next few years. The Scottish Government has, for example, suggested that there may be minimum standards on the near horizon. We've also worked with Tarbase, with Heriot Watt. We've done lots of stock profiling. We've been looking at over 70 different housing archetypes. Certainly with the City of Edinburgh Council, we started off looking at what were the baseline number of about 25 housing archetypes. If you visit some of the Scottish Government web pages, you'll actually see that there's a narrow definition. But for us, any significant variance which will affect the rating on a property means that we've identified a new sub-archetype. We've also been looking at the use of DEMSCOT, but for us it was too generic and it lacked tailoring or detailed outputs. And certainly in our discussion with City of Edinburgh Council, who were keen to persuade us to work in partnership to develop a tool, which is what we're now going to go on to describe, they themselves said that DEMSCOT really wasn't delivering the decision-making tool that they required really to meet the sort of challenges for the next few years. Putting this within the legal context, from the top, the Scottish Climate Change Declaration, we know that there's a 42% carbon reduction target by 2020. I think we're going to very slightly underscore meeting that, but the real challenge is 2050. So that's 80%, and that's an 80% carbon reduction. In a lot of the work that we've been doing, we can see that the first 10, 15, 20% is reasonably achievable, but meeting these more long-term targets is really challenging. Housing Scotland Act introduces a whole range of issues, including the introduction of the home reports for house sales. The interesting one for us in Edinburgh is the Tenement Scotland Act, because from 2010, energy efficiency standards are included as one of the repairs that can be introduced through a majority consensus within a stair. As I say, there are something like 9,000 common stairs within Edinburgh, so lots of households who have to be engaged to actually work together. The Energy Efficiency Action Plan for Scotland clearly is a perspective on where we're going next. There's interesting reference to the private rented sector. In Edinburgh, the private rented sector has grown from 7% in 1995 to about 22% now. So it's a major challenge, again, to secure the participation of all the players. In the action plan, there is reference to 2018 and the possibility that minimum standards in terms of the energy performance certificate rating will be introduced. And if current funding for energy efficiency work through the Scottish Government is read correctly, you'll see that a minimum energy efficiency standard of about 8 of E on an EPC scale appears to be the benchmark above which properties will be deemed to be sellable, rentable. Those below, we're looking at the next few years as a challenge for us to ensure that those lower rated properties can actually be brought up to the standard. Green Deal is on the horizon. We know that Green Deal is going to be introduced by the end of the year, and it's going to change the way that energy efficiency particularly is funded across the UK. It's going to remove access generally to grants. There will still be some funding through the energy companies, through the energy company obligation. But the challenge with Green Deal is persuading householders to take on a low interest loan paid through the savings that they should be expecting to achieve through installing those measures in the first place. And so understanding issues around household occupancy and modeling is really important in terms of delivering a product in terms of Green Deal and energy advice that householders can really benefit from. After 2015, we don't know what the direction is in terms of the Scottish Housing Quality Standard, but we can assume that it's going to rise. It will need to rise in terms of achieving higher standards and getting some parity with the Scottish building standards, which have significantly changed over the last few years. Key thing is there's a far greater focus on bangs for bucks. right, what can you get in terms of squeezed budgets? So how can you demonstrate one option compared to another? That's really where the design tool came into being as a concept. In terms of early development, Council stated they needed something to enable them to actually meet really challenging targets in terms of the Scottish Housing Quality Standard. In 1981, around about the time when Right to Buy came in, the Council had 69,000 properties in Edinburgh. Over 2/3 of that property has been sold under Right to Buy. Over 23,000 properties are in mixed tenure blocks, and only 45% of these are council owned. So the council has a minority interest in many blocks, but to achieve its own regulatory standards, it needs to get other people on board. But there's also a good news message here, because the council itself can work with and can help owners, landlords in the residual properties in these stairs to achieve higher standards themselves. We know, for example, that energy performance certificates over time could influence both borrowing for housing finance, but also in terms of rental income that might be achieved. There are certainly examples in Australia where the Energy Efficiency Rating Scheme has delivered this. So in Edinburgh, mixed tenure is a significant challenge, and so the tool, to a certain extent, addresses this, because if we can demonstrate what the options are to achieve standards for one party, then it can be seen very much as a tool for opening up discussion to get other owners on board. In terms of the early development, it was clear that the tool would need to have a far wider applicability, not just in terms of council stock. The council has reduced its percentage ownership of housing in Edinburgh from 30% in 1995, and it's probably down to about 9%. So it's a minority landlord. You've got, as I stated earlier, the private rented sector, but you've also obviously had a significant interest in owner occupancy itself. In terms of thinking about a tool, we need to think about how it could be rolled out, how it would be relevant to partner organizations. And we made an early decision to look at an Excel-based tool, because local authorities are familiar with Excel in terms of its spreadsheet design. The key thing was that we didn't want to develop something that would be static. It needs to be dynamic, in that some of the background data needed to be updatable over time. And in terms of the ongoing development time that would be required, a spreadsheet could be fairly rapidly updated. And certainly if you've got separate related spreadsheets where you can import all updated cost data on a regular basis, it means that development costs and modifications would be generally low. What I would say at this stage is that we've been piloting this with City of Edinburgh Council, and we are continuing to pilot it, and it's something which Kickstart have generously agreed to provide us with additional funding to extend that further. The preferred brief from the council was that it needed to present a range of solutions, so a different package of measures. We needed to be able to compare capital costs. So again, bangs for bucks. We needed to identify associated costs and measures, so it had to be very measure specific in terms of identifying one investment compared to another. It also needed to accommodate the complexity of hard-to-treat properties, particularly flatted properties, those with a common stair. So I return to the example that I gave earlier of Cableswine House, where you've got 20 different archetypes within a building where, on external inspection, you would think 2 or 3 variants at most. We'd also need to use representative energy data. We also needed to provide better information to engage other owners. So that's, again, that cross-tenure partnership. We also, for the council, and for other social landlords, needed to help them demonstrate compliance with both current and future standards. So we're looking at Scottish Housing Quality Standard, which has a minimum SAP rating in relation to properties which are electrically heated or gas. We needed to also look at it in terms of fuel poverty. Fuel poverty, the Scottish Fuel Poverty Statement has got an aspirational target to eliminate fuel poverty as far as possible by the year 2016. Fuel poverty is a combination of energy efficiency standards in property, fuel costs, but also household income. So one of the things that we would be looking at with this was, if you're looking at a particular property, what would be the typical pattern of occupancy? Is it household? Is it single person? So the size of the property itself would trigger the likely income and therefore affordability for the householder. Fuel poverty is defined as a householder having to spend more than 10% of their income on energy after housing costs. It affects about 1/3 of households in Scotland who are spending over that threshold. And as fuel costs go up, for every, I think it's for every 1 degree increase in energy costs, I think it adds about 8,000 households in Scotland. And it's a growing issue. But with fuel poverty, we were looking to fuel poverty proof properties through the modelling tool. And the way we would do that is, let's assume that people are actually, their lifestyles change over time, they return to a situation, or they're actually completely dependent on state benefits. So they may have an adequate income, but loss of job, bereavement, or other issues within the household. How can we protect them? How can we make the property affordable? The third one on this list in terms of compliance is obviously meeting those CO2 targets, a fundamental raison d'etre in terms of Changeworks, but also much of the work done at Heriot Watt. The other issue in terms of the preferred brief, and this was a really ambitious one, was to calculate Green Deal eligibility in terms of demonstrating that the measures we were suggesting could be compared through using the tool would actually calculate Green Deal eligibility and meet it. The initial spreadsheet, the key thing about the spreadsheet is that it imports information. A lot of that is done manually. Ideally, we would have a management database that would cleverly do this, but essentially, dimensional data from record drawings is really important so that you've got an absolute accuracy in terms of understanding things like the external wall areas, exposed areas, a range of different things, window openings, for example. Also, variable data in terms of information that could be updated on a regular basis. My reference to the fact that the tool had to be managed and economically updated on a regular basis. So one of the things we were looking at was real life costs for doing things. So within the tool, we wanted to build in cost data for actually carrying out measures. And so what we've done with the tool as it's been developed is we've taken scheduled rates from our partner, from City of Edinburgh Council, which have enabled us to state what unit costs would be for a square meterage of external insulation, dry lining, or other measures. Also looking at energy efficiency standards, so looking at the Scottish Housing Quality Standard, because part of the dynamic of the tool is that the outputs demonstrate whether or not you actually meet threshold compliance with standards at that particular point in time. The obvious other issue, because it's one of the contributors to fuel poverty, is energy costs. So being able to have a cost table that can be updated on a regular basis is really important. The third one is obviously household income. And so again, we return to the issue of assuming that the householder is totally reliant on state benefits. And so again, the threshold is updated as and when benefit levels change over time. The table on this sheet actually talks about minimum SAP standards in relation to meeting Scottish Housing Quality Standards compliance, and it's actually in something called Criteria 35. The initial work that we did on this was that we were asked by the council to look at one particular house archetype in Edinburgh, and that was no fines property. And they said, if you can come up with more than one scenario, it would be extremely valuable for us, because we don't necessarily want just one right answer. We want to be able to compare different ones. So we also looked at low, medium and high cost packages. Slight health warning on this, and that is in terms of higher cost measures, one of the factors that needs to be taken into account is disruption for the householder themselves. How much can be done retaining the household in place? Social landlords don't have lots of spare property where they can decant tenants to. So there are issues about how much can be achieved without too much disruption to the tenant. But we looked at low, medium and high cost packages and the cumulative SAP improvements, but also carbon reductions, but also accumulated capital costs for each of those three scenarios. So it was capital costs per properties, SAP scores, whether or not you got pass or fail. So for example, with the tool, were the Scottish Government to identify through a consultation that they were minded to raise a SAP score to a certain amount, then we can factor this into the tool to see how well we are achieving this. CO2 savings, but also that crucial thing in terms of social tenants, which is fuel poverty, pass or fail. The initial spreadsheet, however, lacked flexibility and adaptability. We needed the spreadsheet to have that facility to be simply updated on the basis of that variable data over time. And it was at that point that we made a decision to apply for Kickstart funding to develop the calculator much further, to draw on the expertise and resources, particularly of Heriot University, so that it was easily adaptable to accommodate data extracting from other modeling tools. One of the background data sets which is in here is that you need to have an NHER survey or something of an equivalence to enable you to have all the household data that is necessary to generate a SAP score. And it will also give you an indicative energy cost for that property. And that baseline against each of the archetypes or sub-archetypes is embedded into the tool now. But the other aspect of its further development was that it had to be relevant for assessing future funding opportunities. So again, it's those twin funding routes, Green Deal loans, or funding through the power companies, the energy company obligation, both of which will come in later this year. At this point, I'll hand over to David Jenkins, who will talk about Heriot Watt's really valuable role in this. Thank you.
Thanks, Bob, and good afternoon. I'm Dave Jenkins from the Heriot Watt Urban Energy Research Group. We're a multidisciplinary research group in the field of energy use in buildings. We cover quite a lot of topics within that field. Lots of building simulation, climate change, adaptation, fuel poverty, and this type of work. For this project in particular, there's 3 researchers working on it, myself, Sophie Simpson and Vicky Ingram. And Changeworks came to us, as Bob and Stuart have already documented, they came to us with a sort of prototype form of a spreadsheet-based model. And they asked us if we could configure the model and improve the user interface with the potential client, potential user in mind. Improve the automation of that model to allow outputs to be generated more efficiently and more effectively. Provide links to other metrics that might be potentially useful for the user, things like Scottish Housing Quality Standards, to see whether particular houses within a portfolio comply to those standards and what you might need to do to those buildings to make them comply. And then things like fuel poverty as well. If you have income information from a particular housing stock, you can start to get a feel of what the fuel poverty risk is in those areas. We also looked at accommodating other input variables throughout the model, things like fuel cost changes, tariff changes, and how that affects bill savings. And I'll talk a little bit about that later on. And then obviously on the output side, as you see when I go through the model, there's lots of output that's generated, but for some users, they might just be interested in the key parameters, the key outputs. And so we've tried to collate those into a series of graphical outputs, so you can put your input in and get that output out quite quickly, quite efficiently,
and see the results not long after you've actually started the model. And as Bob's also mentioned, we wanted to allow for further updates throughout the model. So we have a series of databases within this model where the outputs and the calculations are based on those assumptions in the database. But we know that lots of things are changing at the moment in the area of domestic refurbs, particularly relating to the Green Deal, but other matters as well. So we've allowed for a facility that will do that. So the tool itself is based in Excel. It makes things a lot simpler in terms of allowing other people to use the model perhaps in the future. It does allow updates to be carried out. But there is the potential there to maybe improve the interface through a bit of clever programming and take it out of Excel, but at the moment it is an Excel spreadsheet-based model. The inputs and the outputs that we've used are based on 3 levels of detail, and this is based on recommendations from Changeworks and the experience that they've got with real building projects. So you have, first of all, the sort of project level detail. So this is really encapsulates every single building that you want to analyze. So this might be a housing association with a large number of buildings in their building stock, and they want to carry out an analysis on all those buildings. So that would be the project level. This big mix of different dwelling types, different occupant types, and in some cases different tenures as well. You then get down to one more level of detail beneath that, and that's the archetype level. So this could be a block of flats, for example, in that picture there. So this might be useful in terms of categorizing the cost on refurbishing your building stock, because you might want to know, well, okay, it costs a certain amount for my entire project, but where's that money being spent? How much was spent on the blocks of flats or the low-rise dwellings that we have? So you can group them under an archetype heading. And then the final level of detail is a sub-archetype, which might be, in the case of a block of flats, one sub-archetype might be one particular flat within that block. So perhaps from the point of view of SAP modeling, NHER modeling, you can describe that block of flats using just 10 sub-archetypes, and then you would then sort of repeat that sub-archetype throughout the block of flats. So you can then multiply up the cost of the refurbishment. But of course, you need to take into account the orientation, in some cases different occupancies, but you would trace that back to the SAP modeling, the NHER modeling that you would have done prior to using this cost refurbishment model. So the client would choose and define their dwellings, and their starting point would be some form of building model, because this is a cost refurbishment model. It's not an energy model as such. You need to have done your energy calculations prior to that, and for various reasons you would have to do that. Again, going back to Green Deal, proving the effectiveness of a particular technology, refurbishment technology that you're interested in. So you would come to this with a series of SAP calculations. But actually, you could even do more detailed modeling, like dynamic simulation models, if that's your particular background, and you could use the results of that type of modeling with the sheet as well. But it is set up for NHER SAP type outputs, because most of the users, most of the clients for this type of model will have been using that type of steady state model. But the data relates to real buildings, and that's quite important, because when it comes to specifying the costs of what the refurbishment might be, you can relate those costs to this very specific type of refurbishment for this particular selection of different building types. And just to mention as well, just to sort of speed up some of the calculations within the model, we have a little bit of programming, Visual Basic macros for those interested in that type of thing, which just allows the model to do a little bit more than it otherwise could have done. So the way we've designed the model is that you can approach this with a number of scenarios in mind, because whether you're a housing association or local authority or whoever the client might be, they might be trying to decide, right, do we go for a low cost, medium cost, high cost option? Or they might be looking at low, medium, high carbon saving options. So you might be wanting to compare different selections of technologies. So what we do with the model is that we group those under 3 specified scenarios. You can kind of see the graph to the right there, which gives you an indication of what that would look like. You then apply these 3 different scenarios to your entire building stock. But what you can do, because some buildings might not be appropriate for some of the technologies, so obviously you can't put cavity wall insulation into a solid wall building, and maybe 20% of your building is a solid wall. So you can opt out of that technology for certain building types. You can be quite detailed in how you apply these technologies. The model will then calculate the cost for your project, for your archetypes, for your sub-archetypes, for those 3 different scenarios. So you get some capital cost estimates based on that. Importantly, other technologies can be added in the future. We have a reasonably long list already in the model describing some of the, I suppose, the more obvious technologies and some of the less obvious technologies as well that you would use as refurbishments in dwellings. But there are plenty of options to add your own technologies as well. If you have the SAP performance or the energy performance of that particular technology, and also if you have the cost data, you can just add that to the existing databases in the spreadsheets. And that will give you some form of visual graphic output that is hopefully meaningful and fairly intuitive to understand as well. And as I say, all that energy use data is based on the kilowatt hour input from NHER. That's quite important because some versions of SAP and NHER, you can get your carbon and cost information out automatically. But we like to use the kilowatt hour information because we can then use our own cost tariffs, our own carbon intensities, and play about with that to see how that affects the cost-benefit analysis of these refurbishment scenarios. Quite importantly, and I suppose what's driving certainly a couple of these sort of spreadsheets within the model is the Green Deal issue. And I'll come to that in a bit more detail in a few slides' time. But a lot of these results are set up to be aligned with the Green Deal criteria. And of course, you can apply this analysis for any size of building project. So everything I've just said, you can apply it to a single building if that is your building project, or you can apply it to 200 buildings. If you have the information relating to those 200 buildings, you can put it into the model. So the calculator itself has 17 individual sheets. Many of these sheets most users wouldn't need to access. It allows, and it's quite important that we were able to do this, is that it allows users with different levels of expertise to use the model. So you might just be interested in the basic input sheets and the basic output sheets. That's fine, you can use the model that way. But for those wanting to get into the more sort of nitty-gritty data, the more detailed stuff, that's all there for you to look at as well. And I'll give you a couple of examples of that in a second. So the first couple of sheets, archetypes, property details, this gives you fairly summary type information that you put into the building. Some of this information is used with the actual calculations, but some of this is just useful for categorization and also for cross-referencing your buildings to perhaps other projects. But it also maintains that aspect that these have been applied to real buildings, and you can put the details of those real buildings into the spreadsheet for your records. You then have to put in slightly more detailed input, and this is when the calculation really starts going. So we have heating systems, openings, and windows that are present in your different sub-archetypes, your different dwelling types. Dimensional data, obviously. So that's the kind of information that many people would already be used to if they've carried out an NHER SAP type calculation. So it's the usual kind of usual type of inputs that you put in there. Then we have the refurbishment scenarios pages. So you need to define what refurbishment technologies you would like to choose for your 3 different scenarios. Just by checking a series of boxes on this list of technologies that we have in our spreadsheet. There's then a cost database where we've got our default costs for these technologies. You can alter that if you have your own costs for those particular technologies, because different size projects produce different costs for the same measure, depending on how much of it you're actually purchasing and depending on how you're installing and so on. So that can all be updated, but we do have these default costs that Changeworks have provided. Then when you get to sort of sheet 9, this is when you start to get some of the main outputs. So first of all, we give you pretty much every metric that we think is useful across all the different sub-archetypes. So sheet 9 is lots and lots of information. And as I say, for many people, that information is superfluous because they've got their own sort of key parameters that they're interested in, and they'll trust the calculation of the model prior to that. But for those of you who are interested in the more detailed information by dwelling, how does this dwelling perform to this dwelling? Does it get to SHQS compliance? Is the occupant likely to be in fuel poor? How do the different technologies perform step by step, scenario by scenario? That's all in that spreadsheet. So there's quite a lot of detail in that spreadsheet. But if you're not interested in that detail, you would probably go straight to sheet number 10, which gives you the sub-archetype summary. So a few graphs and figures that we think are useful for whoever might be using this model. So again, the sub-archetype would be dwelling by dwelling. Each SAP result, in effect, has a sub-archetype associated with it. You then have a slightly higher summary, which is the archetype summary. So again, there you might want to compare archetype 1, which might be a block of flats, with archetype 2, which might be a low-rise development. You can see how the relative costs, and as Bob was saying, the bang to buck for those two different archetypes. You can do that comparison. And then you get to the project summary, which some people might go to straight away. So it just gives you your total cost of the refurbishment scenarios, the 3 refurbishment scenarios, the average effects on SAP ratings, the average effects on carbon emissions, and these kind of metrics. We then get to a series of 3 sheets for the Green Deal scenarios. I'll explain those in a couple of minutes. You can then put in additional information relating to income of the occupants within your building stock, if you have that information. And if you're able to do that, then you're able to have this fuel poverty analysis that we carry out in the sheet. So we can compare the energy bills that we're predicting with the income of the occupants. But because we're using our own fuel tariffs, we can play about with, for example, future fuel tariffs, fuel switching, to see how that affects the fuel poverty status of the occupants. Then there's a couple of other databases in the spreadsheet, which gives you the cost of fuel. So the fuel tariffs, you can choose single tariffs or split tariffs. So we allow you to do that, and there's a choice of different fuels. And then there's the cost of measures, which I mentioned, which you can update, but there's some default values for what we think, or what Changeworks think, is the cost of these refurbishment technologies. And also to mention, there is a report available that provides step-by-step instructions on how to use this tool, regardless of how detailed and how much detail you want to use the tool. It's still obviously in sort of prototype form at the moment, so it's not quite fit for public consumption. And I'll mention the additional work that we've got planned to improve the model further. But this is all going to be documented, so it will all be quite clear as to how the model is used and what you will use the output for. So the first sheet in the model, as I mentioned, is about collecting information on the archetypes. So it looks something like this slide. So you can choose up to 10 different archetypes. Within each archetype, you can choose up to 10 different sub-archetypes. So you can have 100 different dwelling types. But then you might have several of each sub-archetype. So you can accommodate more than 100 buildings. But you can have up to 100 different dwelling types. And it's up to you how you subdivide that. We also give you the option of describing what type of tenure that property might be. So you can talk about the percentage social housing, the percentage that might be privately owned or privately rented, and that can be used in some of the outputs so that you can decide where the money is being spent and how you might raise that capital, for example, because that will be different if you're in social housing or in the private sector. So that's the archetype sheet, just very, very simple. It's really just a labeling exercise at this stage, but whatever numbers you put into here is then picked up throughout the rest of the sheet and affects the amount of data that's generated. Then we start to put in slightly more detailed information. On this sheet, I've not got every single parameter on this slide, but this is the type of information that you start to put in. Some of the information is again about categorization. It's about sort of cross-referencing, so you don't need to put in the property address, but you might wish to do this so that when you look at the carbon to cost outputs, you can trace back to see what buildings are costing what amounts. And then information like ventilation, heating and hot water systems, these are parameters that start to get used by the calculation itself. And with respect to heating and hot water, you can be quite specific as to what boiler you're putting in. There's another sheet where you can define your heating system in a reasonable amount of detail with the brand and the size if you want to give it that. Again, that's useful for cross-referencing, so you can know what boiler you're replacing if you are planning on replacing it. And then things like what type of tariff you're on, that's very important with the cost, the energy bill calculations later on. But as I said before, most people who carry out SAP and NHER type analyses should be familiar with this type of input, and it's designed with that in mind. So some of the databases that I mentioned, we've got a couple here on the cost of the measures and the fuel tariffs. And again, the slide doesn't show the complete list of measures, but you can see the usual suspects: cavity wall insulation, roof insulations, and so on. But there's quite a long list of different technologies in there. And again, providing you have the information, the cost information of that technology, and the energy saving effect of that technology, then you can put a new technology into that database, regardless of what that technology might be. We've got a facility for doing that. And then the fuel cost, as I mentioned, it's important to get that single and split tariff option in there, because that has an effect on the cost savings of a lot of technologies. And we've put in the usual fuels that you might expect in most dwellings in the UK. Again, there's not a complete list there, because you can also have biomass as an option, and so on. So that's based on available information for typical tariffs, but once again, you can quite easily change that if you have a specific tariff that you're looking at. And of course, if you're using this model in 5 years' time, you'll have a different set of tariffs, a different set of cost measures. Anyway. So the Green Deal sheets, and this is also becoming more and more important as we get closer to autumn of this year, which is supposedly when the Green Deal will come into place. The latest statement from DEC is that that's going to be a soft start. So we're not expecting hundreds of thousands of homes to be signing up to the Green Deal in a pre-Christmas bonanza, but the Green Deal is there. It's an important part of refurbishment policy at the moment, regardless of whether you're pro or for the Green Deal. So as a result, this model does need to pick up Green Deal eligibility. So we have 3 Green Deal sheets, one for each refurbishment scenario that you've chosen. So you've chosen the scenarios based on these technologies that you're interested in installing. The first box, which you might be able to see at the top of the spreadsheet, which says 1A, you'll choose your specific sub-archetype in a drop-down menu. So if you've defined 20 different sub-archetypes, there'll be a drop-down list there of 20 sub-archetypes. You choose the one you're interested in. You run it through your particular refurbishment scenario, and you're given a Green Deal type assessment throughout that sheet. So it'll tell you, obviously, how much it costs, how much you save, what the payback will be. You can also apply a rebound effect. At the moment, this is done in a very crude way, but we're going to be developing that in the next phase of the project. But the rebound effect is obviously when post-refurbishment, someone changes their actions such that you don't see the energy savings that you thought you were going to get. And that's particularly true in low-income and fuel poverty homes, where you might see someone turning up their thermostat after a refurbishment so they don't get the energy saving that you thought they were going to get. And that's of huge importance with the Green Deal, because it completely affects how the loan repayment scheme might work. It completely affects whether there's a sort of attraction there for the occupant for signing up to this loan system in the first place. And then other information there, you can put in your loan interest rate. At the moment it's there at 4%, but I'd suggest the Green Deal as it stands, you're looking at interest rates of 7, 8, 9, even 9%, because there'll be market rate interests. So you can put in the interest rate that your Green Deal loan provider has specified, and then you can see the year-on-year effect of when you have to pay those loan repayments and how much it costs compared to the loan that you've got out. As I say, we're looking to develop this at the moment, in particular looking to add in information around the energy company obligation scheme. I'll come to that in a second. This is just a very simple example of some of the graphical outputs we've got for in the spreadsheet. So clearly you're going to want to know what the capital costs for all properties are for your particular project. What you might be able to see in these graphs are two different archetypes listed. So for this particular project, there was only two different archetypes. So again, that might be a block of flats and a low-rise development, or two different block of flats. And this will tell you where the money's been spent in terms of total amount of spend. So you can see the vast majority for this particular project has been spent on archetype 1 for whatever reason. And as a result, the majority of the effect on the carbon emissions is associated with that archetype. And you've also got the average SAP rating improvements across those archetypes. Probably of more use is if you wanted to look at the effect of the SAP rating for the individual sub-archetypes. Sometimes when you average certain quantities together, you don't really get a picture of what's happening. So that's why we have this more detailed sheet that's there for you to look up. So you can see, for example, what happened to dwelling number 1A in terms of the SAP improvements as a result of my 3 different refurbishment scenarios. And that's all there for you to look at. But this is designed with simplicity in mind. So most users will get something out of this. Some users will want more detail. And as I say, that's there if you require it. So that really sums up the work that we've done, the first phase of the Kickstart work. So we're now starting on the second phase, which is to take it to a slightly more detailed level. We want to have slightly more information there, which will enable us to quantify a rebound effect. And for those who've looked at rebound effects, take-back effects in the UK domestic sector, it's not a thing that you can quantify with any great certainty, but you do know it does happen, and it is an important effect. So either by using sensitivity analysis or trying to relate the likely rebound effect to the income of the dwellings, we'll be looking at trying to incorporate this into the spreadsheet calculations, in particular the Green Deal calculator, because as a result of a Green Deal loan, you'll put your refurbishments in, there'll be a certain amount of saving for the occupant, but the majority of the saving will go to the Green Deal provider. So the question is then whether the rebound effect in a particular dwelling will actually cancel out any of the saving for that occupant. And the sensitivity of that is quite important. And it's, we've run this for theoretical situations, and it doesn't take too much for the saving to the occupant to be wiped out by this rebound effect, because the majority of the savings from the technology is going to go to the Green Deal provider as the Green Deal payment. So we're going to incorporate that. We also want to introduce more about the energy company obligations scheme, as I mentioned. Current studies suggest that the ECO will have to be quite a vast pot of money to deal with fuel poverty, to deal with buildings needing solid wall insulation, affordable warmth, all these different issues. So it'd be important for a client to demonstrate to themselves for a very particular building portfolio, stock of buildings, how much money they would expect to request from an ECO fund and how much would be borrowed from a Green Deal scheme. So with the new Green Deal sheets will look at a balance between ECO and Green Deal for a certain building project to give the user an idea as to how those two things play against each other, whether they can work in unison, and whether they can borrow the amount of money that we're suggesting they will need to. Again, incorporating Golden Rule and so on into the Green Deal. We're also quite keen on applying different CO2 intensities for future scenarios, because the thing to remember is a lot of the technologies we're talking about might have 10, 20-year lifetimes. Now, during that time, energy tariffs are clearly going to change. CO2 intensity of the grid is clearly going to change. So these are issues that are often missed out because they are quite complicated. They are quite difficult to pin down. We can't know with any certainty what a future gas tariff is going to be in even 5 years' time, let alone 10 years' time. But we want to provide some form of sensitivity to the model, which will allow us to put in these future generation scenarios. So if we go down the route of a certain form of off-site generation, what will the CO2 intensity of the grid be? How will that affect the carbon savings of our particular refurbishment scenarios over the next 10, 20 years? So we'll be doing that, and you can do exactly the same exercise with fuel tariffs as well. Again, it's very difficult to pin down specific values for what future fuel tariffs will be, but it's nice to have a model that will try to accommodate estimates around that. Also, with the fact that we've got these 3 different refurbishment scenarios running side by side means that, yes, you can do a low, medium, high cost scenario, but you can also have your 3 refurbishment scenarios linked to certain policy targets. So refurbishment number 1 could be linked to ending fuel poverty by 2016, for example, and you could see, right, what number of measures do I need to apply to my building stock to get to that level, or the 2020, 2030, 2050 targets that we have for carbon savings. You can have your refurbishment scenarios actually linked to those targets. Again, a housing association or a local authority can estimate what they need to do to their building stock to meet those targets, to show that they're trying to work towards those goals, even if they are very, very challenging goals. And also to account for more radical changes to a certain portfolio of buildings. So again, if we're talking about measures and technologies that are going to last 10, 20 years, even more in some cases, then what's going to happen to that building stock over that time? So demolition rates, changes to property management and property tenure. So we plan to incorporate that as well. So it makes the model more versatile, it makes it more sensitive to future uncertainties as well. And that's going to be a key goal of the second Kickstart fund. Just before going on to the questions, I just also wanted to mention a conference coming up on the 20th of April in Edinburgh, being organised by Changeworks, on solid wall insulation, exploring barriers, solutions and new approaches to insulating Scottish solid masonry walls. For anyone involved in either the modelling or monitoring side of traditional Scottish dwellings, solid wall insulation, of course, always comes up. There's many issues with how we model it, how we measure it. There's many issues with what happens to a building when you carry out external or internal cladding, what happens to the characteristics of that wall that might have been standing there for 100 odd years. So that's on the 20th of April in Edinburgh, and I'm sure Changeworks would be happy to provide more information on that if you contact them. So to introduce the Q&A session, I'll hand back to Branka.
Thank you very much. Excellent. We have quite a lot of questions already here. So we will start with the first one from Mohammed Abdel Wahab of Razala Consultancy. How are you going to identify the associated costs of measures given the uncertainty of the installation and maintenance costs of some innovative low carbon technologies such as fuel cell based technologies?
I think in terms of how we envisage this model being used initially, those technologies are not the sort of things that housing associations would choose because of the costs on them. But the model does allow us to do is, if there was pilots done on these type of technologies, then once you do hone in on the costs that associate with them, then we can build that into the model. But at this stage, that's not something we envisage it doing. We can probably cost up more common renewables that in terms of deployment. We understand the maintenance costs. Fuel cells are pretty innovative in terms of their application within the housing stock at the moment.
Anyone else to add here?
Yeah, I mean, I think, like I said, regardless of your technology, if you have the information about that technology, then you can incorporate it into the database. But it's not just with the more innovative technologies like fuel cells. Even things like loft and cavity wall insulation, over the next couple of years, the prices of those technologies are going to increase because subsidies are being removed. So the model needs to, even for something as simple as the most simple refurbishment measure, the model needs to incorporate that. The model needs to be versatile enough to do that. But that does mean that the user of the model needs to come to the model with their own cost estimates, while at the same time, if you like, the management of the model, which is Changeworks, they'll be updating that database so that in 12 months' time, the fact that loft insulation has gone up in price, that will be there in the model. But these prices are not static. So, but it's not just with the high-risk technologies, the innovative technologies like fuel cells. It's true across the board that prices will change.
Mohammed raises an interesting point when he talks about maintenance This isn't something that is directly built into the tool at the moment, but clearly there is an opportunity, so I think we'll start discussing this after this event. I made mention in my brief presentation to the fact that there are other associated costs that also need to be factored in. And they could be management cost reduction in terms of certain works being carried out. But there are all the consents and other issues which inevitably come in when you do work beyond a certain scale. So they in turn could also be included in this, in the further developed model.
One more general question from Tony Cowling. Don't you need laws in place to make sure that landlords do something rather than nothing at present? Any comment? Yeah.
Well, the tolerable standard's been upgraded. It's not the most ambitious target at the moment in terms of energy efficiency. Things are getting better. Private tenants will have the right to request and hopefully secure improvements in thermal efficiency in their properties within about 2 years. I think that's the Scottish Government's kind of horizon on this, but I did refer to the 2018 date when it looks as though there may be minimum standards for properties for sale but also for rent. So landlords will be motivated. It's either carrot or stick in this situation. Much of what we do is carrot focused, so hopefully this tool will deliver that incentive.
Here is a question from an international viewer, Ibitola David. I observed the ideal of energy efficiency retrofit is nice, but is there any way some of these products or tools could be introduced outside Scottish environment, especially in Africa, where energy is being wasted without any recourse?
What's kind of the beauty of the model that we've created with Heriot is that it's quite adaptable, and it could be modified to take other modelling software. At this point, it's NHER. We've tested it on. It's probably going to move towards RDSAP because that's the Green Deal. But outside that, it could in theory be modelled if we could finance the development costs of doing that. Then yeah, that would be a good thing to do.
I mean, there are issues with other climates. I mean, yeah, if you've got the energy performance estimates from whatever model you've used, if you've got the cost of the measures, then of course you can use the structure of the model. What the slight problem with somewhere like Africa is, as opposed to Scotland, if you make a house in Scotland more airtight and you insulate it, you'd probably still be okay in terms of overheating. It probably won't overheat in the summer if you do it properly. However, in Africa, that's obviously not necessarily going to be the case. So you might make a change to the building which makes it better by some measure, but then that causes an additional risk that wouldn't be picked up by this cost benefit model. It would have to be picked up by the energy model that you use prior to using this.
A question from Dipanita Das. What is the difference between the contents of opening schedule and window data in the calculator?
That's the openings refer to doors and windows. Okay, so there's a database. One's a database of the type of openings that you've got, including windows, and then how you assign those different openings and windows to the specific buildings. That's in the other sheet. So one gives you the ability to find a list of different openings, and the other sheet tells you how those openings are going to be applied to your specific sub-archetypes.
Okay, thank you very much. A question from Nick Pershaus. If you used certain assumptions and scaled up, could this tool be used to work out the CO2 energy savings that could potentially come from the Green Deal for the total Scottish housing stock?
I know we're ambitious, but I think, this tool is very much focused at a small scale in terms of reflecting very accurately information about archetypes and sub-archetypes. Across Scotland, there are so many variables in terms of location, different local building types and the like, that I dread to think how many years it would be before we could come back here and give a similar presentation, but talking about the wider Scottish housing stock. Having said that, it can be applied to individual archetypes very successfully. So we're very keen and enthusiastic about speaking to housing providers, house occupants elsewhere, but to give a general picture across Scotland, it would become too generic in terms of its outputs.
And it's very difficult to, I mean, 2.5 million homes or whatever it is in Scotland, it's very difficult to represent those with a smaller number of sub-archetypes. So we use up to 100 sub-archetypes in this cost-benefit model. To represent 2.5 million homes accurately, you'll need a lot more than 100 sub-archetypes. So personally, I wouldn't suggest using this model in that way. But I mean, there's also limitations to the SAP models that you might be using to generate the energy consumption in the first place. Bob mentioned climate in particular. That's not represented particularly well in SAP at the moment. So the short answer is no, but it does have the potential to be applied to larger groups of housing.
We could take a particular archetypes that are common throughout Scotland and are problematic, and you could use that model to calculate up for that specific archetype, which could be quite interesting in terms of targeting particular problem buildings, which most local authorities would find. But I think that would possibly be the limits of it. We've got DemScot as a more strategic tool that gives you sort of a broad brush picture at that level. So I think that would be the difference between the two models. This is really going down to a degree of accuracy, and that entails a certain degree of time to input the data. And there's a lot. I think at Edinburgh, Bob mentioned this, we found 70 archetypes within the council stock. So that's not including the private sector. And the council, remember, haven't really built anything for the last 20, 30 years. So you can imagine how many different types of property there are in Edinburgh alone. And I think it would be a wee bit of a stretch to use the model for that type of exercise.
Thank you very much. Here is a question from Ruth Dwyer of Transition Edinburgh South. How accurate do you find the energy demand levels when basing on NHIR results, which suggest temperatures of 21 degrees are necessary in living spaces, or do you adjust for this? These temperatures are much higher than most people require, especially in tenements, and also go against the recommended reduced thermostatic control temperatures.
I think I'm right in saying that NHERs do allow you to demonstrate that the householder is not selecting what is called the standard heating regime, which is a certain number of hours of heating during the day and evening, but it also allows you, I believe, to vary the internal temperature as well. Having said that, one of the issues that's going to come out of our next stage work is looking at that variance in terms of household temperature. A lot of people who may be more environmentally sensitive or just far more sensible may select a lower temperature, but we know that the recommended temperature for good health within the home means a temperature range of between 18 and 21. Some people prefer cooler temperatures, others need warmer.
Yeah, I mean, there are at least two groups of problems for this type of model. One is the restrictions you might have on the input that you're able to use with them, particularly if you're using SAP and RDSAP, again with respect to the Green Deal. There are restrictions on the input that you use, and that can affect the accuracy of the models quite severely. And there's obviously limitations to the calculations that are used. These are steady state models. The building physics, if you like, behind the models are relatively simple compared to other models. And the thing to remember is a lot of these tools, particularly RDSAP, it's a compliance tool. It's not really, initially it wasn't really designed to estimate energy bills. That is now what it's being used for with the Green Deal. So it's not just the question I mentioned, what level of thermostats is on. That's clearly very important. But there's lots and lots of other issues that make it is very difficult using SAP-based models for this level of detail. But that's not a fault of the cost-benefit tool. We have to use the available tools that are out there, and SAP is the tool.
A question from Gordon Brown on Brown and Wallace. When do you anticipate the tool will be fully developed and rolled out? Who will it be available to, and how much will it cost to use?
The model is complete and tested, and we know it works. What we're doing now is we're developing 2 case studies over probably the next month into April, just to try it out with different housing associations. So we can take raw data that we haven't seen before, because there is an issue about the quality of the data will affect how much it costs to run the model, if that needs a lot of cleaning up and tidying up, and there's any issues with inputting. And we're fairly confident there won't be any issues, but we want to test it out before it's fully available to market. We would be happy to speak to anybody right away about using the model, and yeah, I think we could say that by May we'd be hoping to work with social landlords or any other housing provider that's interested in running that, and at that point we should be able to give fairly good, reliable cost estimates based on having done fairly extensive testing, not only on what we've done with City of Edinburgh Council, who we're used to working with, we understand their data, but with other housing associations, including what we're looking at is using different types of data, some sort of rural scattered properties, that side of things, just to see how it comes out. So if people want to contact us, we can start to give cost estimates next month. Obviously, we want to make the cost as low as possible for rolling this out. It's about delivering the benefit to tenants from these retrofit strategies and making things possible. Changeworks are not-for-profit organisation, so what we're looking to do is obviously recover the development costs so far, and also be able to update and improve the model, because the more we use this model, the better it will get in terms of the cost data that's behind it and the number of archetypes that we use it with.
Thank you. A question from Alistair Kant of Lister Housing Cooperative Ltd. Or comment. I think disruption to tenants, occupiers, is a crucial element, and at Lister we are looking at doing less effective in terms of energy conservation, but they are much less intrusive. Less intrusive measures are easier and cheaper to do, as contractors factor in such disruption costs in terms of their charges. Any thoughts?
Decants are a major issue. What councils tend to do, because they, in terms of Scottish Housing Quality Compliance, it's not just an energy efficiency issue, it's to do with modern kitchens, bathrooms, and a range of other facilities. So they've got lots of boxes to tick. And what they will do is, in one 3-year cycle, they may carry out certain work, then go back and do additional work. And the same would be said for energy efficiency work, but there is a major economic argument for saying that the work should all be done pretty much at the same time. If you're putting scaffolding up, you can do window replacement, you can do external cladding, you can do roof realignment and everything else. But in relation to what happens with the tenant, our challenge is that we do not have sufficient spare housing stock to decant. We undertook a piece of work using the Technology Strategy Support Board funding about 4 years ago, looking at an archetype in Edinburgh, and we looked at what could be achieved through basic measures and then really looking at radical changes in terms of renewables technologies. And we reached a threshold where it became obvious that the householder would have to be decanted. We then looked at the costs of decant, compensation for the tenants. It added on about 30% onto the budget. So there's an issue about practicality. Can you decant? But also, can you afford to? Because also there's the associated loss of rental income as well during that period. My feeling is it's probably something between the two. In an ideal world, we would create a village somewhere in central Scotland and decamp people into it so they got environmental education and a holiday and then move back into a splendid energy efficient home.
Excellent suggestion. A question from Huda Salman Salman at Robert Gordon University. Do you agree that such tool could be adapted easily to calculate the required benchmarks for other types of buildings or refurbishment projects such as hospitals, NHS?
Part of the problem again stems from what model you're using to estimate the energy savings, first of all. Particularly with a building as complicated as a hospital, but any non-domestic building, if you start using, when we have SBEM, which is the steady state model equivalent for the non-domestic sector, as we use SAP in the domestic sector, and I think it's the output is more complicated, the output's slightly different, the buildings are certainly very different, and personally I don't like using steady state models with non-domestic buildings because I think they're too complicated to do that. So what you'll have is far more complex output from your energy model, and so that won't necessarily tie in with how this cost benefit model has been set up. I think you would need a new cost benefit model to use it with more complicated buildings like hospitals.
I think the differences with domestic, there's lots of common archetypes, and this is where the strength of this model is. It multiplies up, and you can identify those different archetypes. With non-domestic buildings, they are often quite unique in how they're constructed. So probably not this model for that particular one. It's very strong in domestic buildings, but maybe not so strong for non-domestic.
Thank you. A question from Sarah Gont of National Energy Foundation. How do you propose including variability based on different post-refurbishment rebound effects?
That is one of the questions we're trying to answer on the second phase of the work, so I can't give you a definitive answer just yet. I mean, there's various work, particularly in the field property sector, by people like Brenda Boardman and so on, also Steve Sorrell in academia, looking at different rebound effects. I mean, you have direct rebound effects, which can be seen on the energy, the dwelling energy bills. You have indirect rebound effects, which are more difficult to measure because it might be someone spending money on a holiday, which has an energy penalty, but it's very difficult to quantify. So I mean, the simplest way of doing it is to carry out a sensitivity. So you'll have your Green Deal calculation page. You'll then have a series of different rebounds, and what you'll be able to see is what rebound actually cancels out the savings for the occupant. For example, that would be a useful output. So you could say, well, okay, this you can go to the occupant or the housing association and say, well, at this point there is a benefit for the householder. They will have an energy saving. However, if their rebound reaches 23%, then there won't be an energy saving. So this is how sensitive that dwelling is to the rebound effect and how sensitive it is to actually getting a saving to the occupant from the Green Deal. So that might be one way that we address it.
Thank you. A question or comment, suggestion from Ken Mackey of Shape Associates. Ongoing maintenance requirements costs must be considered for all on-site measures. Do you agree? If so, I'd wish to see it incorporated in your calculator.
Yeah, that is true. In terms of where the model is now, it's focused more on insulation-based technologies, which shouldn't have major ongoing maintenance costs. But for other technologies, such as boiler upgrades and things like that, it would be reasonably easy to understand the costs to incorporate into the model from people like councils. They know how much it costs to service a boiler and do annual safety checks and things. It does get more complicated for the renewable technologies because the maintenance cycles on them are not so certain. I think that's where we'd have difficulty building these things into the model. For instance, we've been doing work on solar PV with housing associations and getting a definitive figure on how much they think it might cost to do maintenance checks on those on the panels is difficult to pin down because nobody's been doing it long enough. Some people are saying it needs a basic visual inspection. Other people are saying they need to be cleaned. Other people are saying the vertical need to be changed every 10 years, every 15 years. So I think that the answer is once we have reliable costs for each measure, yes, we want to incorporate that into the model.
I think it's a really valid point that's raised in terms of the add-on costs. It's one of the things that, particularly when people are looking at renewables, they're not factoring in all the specialist costs of actually preparing plans, submitting them for warrants or planning permission. So if we're going to be comprehensive, then we probably have to factor that in as well. We are currently working on a separate project which is looking at community buildings, and one of the issues that arises in relation to putting certain technologies in is the additional burden in terms of insurance costs. So again, how far does one stretch this? I'm sure these can be added in at a reasonable level, and we'll try and be as comprehensive as we can.
Yeah, I mean, it's a good question as well, because, I mean, as we're putting together this Green Deal calculation sheet, we would potentially have the ability to add in a maintenance cost every year, every couple of years, relating to the technologies that we put in. But one of the reasons why this is such a good question is that I think within the Green Deal scheme, this is an uncertainty as well in terms of how maintenance costs are going to be paid, because someone, whether it's a private homeowner or a housing association, gets a loan, a large loan from the Green Deal scheme. So that's the capital cost sorted out with, but then that particular technology or group of technologies has a maintenance cost associated with it. So who pays for that maintenance cost? How does it get paid? And how does that factor the effective payback of that technology from the point of view of the occupant and the loan provider?
The other issue with maintenance costs is you could be talking 10, 15 years into the future, and you don't know what the maintenance cost would be then, and that's the tricky thing. As these technologies become more deployed, you would hope the costs will come down, so that would be difficult to incorporate into the model with any certainty. But what it can be is quite transparent, and you can put allowances in there, such as for solar PV. We would normally put an allowance in to replace an inverter in 10 years' time, and the cost would be somewhere in the region between £500 and £1,000. But who knows for 10 years? But you do have to take that sort of long-term approach when you make these calculations to give the client the right information.
An example of where maintenance costs are not being factored in is actually one of the most excellent programs the Scottish Government has come up with, and that is the central heating program. A lot of low-income households benefited from getting free central heating systems installed in their home, but at the time, and I'm not placing blame here, there wasn't necessarily a focus on what would be the ongoing costs of the households to actually get boilers serviced on a regular basis. So yes, it is a major issue.
Okay, thank you very much. We don't have any more questions from our online viewers, and I think we are now close to 2 o'clock. So first of all, I would like to thank our speakers, our online audience, for contributing with their questions. And I would also like to advise you about 2 forthcoming events planned by CIC Start Online. The next webinar that we are organizing is entitled Evaluating and Improving a Model for Reducing Fuel Poverty. That was a study undertaken by Edinburgh Napier University and Solas Scotland Ltd. And after that, we have a webinar on developing homegrown natural fiber insulation products, a study undertaken by Glasgow Caledonian University and Craft Architecture. So we look forward to welcoming you at our forthcoming events, and thank you for watching. Thank you very much.